Warning, this episode of WeatherWise, we are going to geek out significantly on radar data. We're talking about what happened during the night of May 20th. The early morning hours, there was a tornado, and it was unwarned for northern parts of Clark County and also Hot Spring County. This tornado was on the ground for only about 3.8 miles. And it did some damage. It certainly did some significant damage to a few houses in that part of the state. Here's the actual map now. We take a look at that. It developed over DeGray Lake and then made its way from DeGray Lake onto the shores of Hot Spring County, affecting the community of Caney, just to the southeast of Bismarck. People were sleeping, and I'm sure a lot of you want to know, why was the tornado warning not issued? So we're going to talk about that. I'm going to look at this event from archive radar data as a meteorologist to see if the National Weather Service missed anything, or if any meteorologist missed anything, or maybe it's because the technology that we have in place is not perfect. Let's get one thing straight. The National Weather Service does a great job here in Arkansas. The Little Rock office, we are always in constant communication. They're always giving us analysis that you don't see behind the scenes when severe weather is happening. And I'm going to show you some of the communication that was going on through that event before the tornado struck. We gave you a brief preview before on exactly what radar is. And radar sends out a beam of energy. That beam of energy hits hydrometeors, raindrops, snowflakes, hailstones, and we get information from that radar that will tell us on how the objects are moving from the radar or towards the radar, away from the radar or towards the radar, which gives us really a highlight on if there's any rotation in the atmosphere. Here in Arkansas, we are covered by 7 different radars. So we got the one radar over Memphis, that's really covering eastern and northeast Arkansas. And then you got Springfield that covers northwest and north Arkansas. Of course, Fort Smith covers northwest Arkansas and even into west central Arkansas. Shreveport does southwest Arkansas. Jackson does a small sliver of southeast Arkansas, and then Monroe. And we do have holes in the radar data. This is the United States. And what I want to point out is all the different radar holes that we have, especially the west. But of course, the west, you don't get too much in the form of, big storms out in this part of Nevada because, one, there's not a lot of population here that really needs to be informed. And then the same story here into parts of Montana, not a lot of population into this area of Montana, also Wyoming, but there's the radar holes showing up into southeast Arkansas, also into parts of southwest Arkansas and northeast Arkansas. There are private companies that have come up with their own radars. You may have heard of Climavision. The only issue with that is we cannot get the data from that private company. I don't know if the National Weather Service can even get that data just yet. We'll keep you updated if that does change, but right now, that data is not being used by any real television stations here in Arkansas. When we talk about the radar beam starts, of course, in North Little Rock, and with the curvature of the Earth, that radar beam continues to go up and up and up. So it gets higher and higher and higher above the ground, and therefore, once you get 100 miles away from this example, looking at, say, Sharp County, that beam from North Little Rock is 10,000 feet. And other beams from other radars, Springfield and also Memphis, are over 10,000 feet. Tornadoes form 5,000, 4,000 feet above the surface is where that mesocyclone typically develops. So that radar beam can overshoot what's happening in the lower level of the atmosphere. Also, radar data, it takes time. It takes 5 minutes for that radar beam to go out, hit the hydrometeors, hit the snowflakes, the raindrops, the hailstones, then come back to the radar dome, along with that, get processed. So it's not technically live radar. It's not happening 30 seconds, a minute. It takes 5 minutes for all this to get ingested into the system and for us to show you what's happening live on air. Any radar app that you're looking at, it's all a little bit delayed. The National Weather Service does have the ability to scan a part of the atmosphere, a section at a time. This is known as sails, and this is when the radar beam is just focused on one part of the atmosphere and they go up and down with the radar beam. But again, that still takes about 5 minutes to ingest that data and for that data to come out. The National Weather Service did use this process on that during the early morning event of May 20th. Next, we're going to delve into the archive radar data and go over each important product that meteorologists use to find out where rotation is located within a storm and how important that rotation is when it comes to tornado genesis. Stay tuned. Now it's time to delve into the radar data from that event. We're going to take a look at pretty much what happened during the hour of 1:57 until 3 o'clock in the morning. The actual tornado was reported to make its way through that part of the state around 2:10 to 2:15. And when you take a look at the radar data, there's a lot of information and there's a lot that we're looking at as a meteorologist across the state, because of course we're not just looking at Hot Spring County, we're looking at all of Central Arkansas, what's coming into Central Arkansas, what's off to the north, what's off to the south. And this is what the radar looked like at 1:57 that morning. What I want to point out is we've got a large area of heavy rain. This is known as the base reflectivity product, and this is what you see typically with the blues and the greens indicating lighter rain, and then the heavy rain, or where the storms are located, that's where the oranges and the reds are happening. But what we are watching as a meteorologist is this intensifying line that's making its way through Perry County, Hot Springs area, Garland County, Hot Spring County, Clark County, Pike County, down through Hempstead County. And when we take a look at the base reflectivity, yes, we're looking at where the heavy rain is, but we're looking at certain radar structures. A supercell, it's easy to identify. It's that hook echo. There's no hook echoes on this image, but there is a line segment, and there is what's known as a QLCS. That's a quasi-linear convective system, and that's what's going through this part of the state. These triangles represent hail that potentially could be falling. When you have a triangle that's upside down, that is this type of software detecting where rotation may be happening. I'm going to put this into motion just to show you what happened in about an hour as that line made its way through. We never see any upside down triangles within this software system, just hail markers going through Clark County and also Hot Spring County. They did issue a severe thunderstorm warning into Grant County and eastern parts of Hot Spring County. Unfortunately, it was already too late. The tornado had already occurred once this warning was issued, and it was a severe thunderstorm warning, not with a tornado possible tag. We're looking at any kink along the line because there could be any little boundary where this line taps into that may start to show rotation. But there is the cell, and it is a little different than the rest of the line. And they were watching this. The National Weather Service did highlight this is acting a little suspicious. When we take a look at what's known as the base velocity, we always talk about this. This is how we show the motion of where the rain, the hail is going. Blue is going to be towards the radar, red is away from the radar, and this is looking from Little Rock. So your radar is located up here. The radar beam by this time is about 5,000 feet to around 4,800 feet. So it is a little bit on the high side, but certainly you should be able to detect a tornado. Then this one is known as storm relative velocity, and we use this. It's very similar to the base velocity, but the difference in this is it takes out the motion of the storm. So if you have a fast-moving storm, you want to take a look at the storm relative velocity in that case. Then we have the spectrum width, and these are all different colors. I don't know if you can see the actual chart on the side. You can't because it's not seen in the frame here, but what we're looking for is where the winds are going in all different directions, and it's very chaotic. And this will be used when we take a look at how everything unfolded with this event. Echo tops, of course, show where the higher cloud tops are, the more powerful, the more strong an updraft is. And your highest cloud top at that point is right over the Great Lake. Another great product that is derived from the software is known as the normalized rotation. The specific name is the NROT, or we just call it the rotation pinpoint tool. It just simplifies things. But you notice there's a bullseye happening just to the south of the Great Lake. But a little blue like that doesn't really have a meteorologist's concern just yet. It's when you get from the blue into green, your concern starts to go up. Last thing we'll look at is the CC. And this is the correlation coefficient. So this tells you, looking at this, where the reds and pink colors are, that everything within that radar beam is all the same shape. When you have blues within the red, that tells you most likely you have different shapes happening, getting lofted into the atmosphere, and you probably have a tornado on the ground. So there's a lot of blue here. This is all noise through Malvern, Sheridan, Benton. It's this area that we're looking at. And the great thing about this is, with this software, I can divide it into 4 panels, and it gets a little complicated. We don't show this a lot on air, but I'm going to do this on WeatherWise because we can walk you through step by step here. So I'm going to go ahead and change this upper right-hand panel to base reflectivity. I'm going to change the upper left-hand panel, upper right-hand panel to base velocity. Then we'll change this lower left-hand panel to spectrum width, and then we'll do the other one on the lower right to the NROT, or the rotation tool. And you notice how close you have to get. You really have to get close. But looking at this, we definitely have some curvature within the signature. So that tells us you got to watch this. This could just be a brief blip, maybe 1 or 2 scans, and then it straightens out. Could just be a gust of wind moving through. When we take a look at the base velocity, we are getting some wind here that is, once again, remember, blue is going towards the radar and the red is going away from the radar. So we've got some wind trying to be kicked into gear within this cell, and there's the blue. So as a meteorologist, I'm still keeping a close eye on this, but nothing that's really screaming out to me, we've got problems, we got trouble. Let's go ahead and go to the next scan. So this came in at 7:02. Which is going to be around 2:02. So they were using sails to get that information. So they're trying to get as much information as possible. So it looks like the information was coming in every 2 minutes or so. Now we have some green showing up here on the NROT tool. So now we have more rotation showing up over to Great Lake. The rotation, not too significant, but it's trying to maybe tighten up somewhat. This does not look that crazy. I mean, it just looks like, for the most part, heavy rain. I'm not seeing any like crazy curvature within this or any bowing out of this segment necessarily, but the spectrum width is highlighting there's a little more chaotic flow within this cell. Could it be a blip? Could it just be one scan? As a meteorologist, you see stuff like this all the time. So as a National Weather Service meteorologist, I'm not going to warn just yet because, one, it's early in the morning and I don't want to wake people up for no reason. I don't want to issue a false tornado warning and have people upset because, you know, it stayed in the clouds. There was nothing that concerning. So they're going to play it safe, and they have certain rules to abide by when it comes to issuing a tornado warning, more than what you're seeing here. They're looking at specifics within the radar data to say, okay, now I can go ahead and trigger that tornado warning, or maybe I want to hold off for 1 or 2 more scans to see how things evolve. Let's go back over to Storm Track 11 now. We'll advance this here again. Now we are at 205. Now we're starting to see a little uptick in the rotation. It's right there. So this little pixel is getting winds of 105 miles per hour. And it's starting to tighten up just enough. So most likely this was rain wrapped. But look at everything else. I mean, if you went in here with an untrained eye, you would not look for something like that because it just looks like a solid line of heavy rain. Until you look at other data, until you look at more products, it starts to tell a different story. And that's exactly what this is doing for a brief amount of time. But once again, is it enough? Is it enough to go ahead and say, okay, this rotation is starting to tighten. Do I trigger the warning? If that continues to tighten, I'm going to have to probably issue a tornado warning. By this time, it's already starting to make its way onto the shore from Clark County into Hot Spring County. But looking at that one pixel right there, 105 mile per hour winds being detected at 5,300 feet is definitely spelling out trouble for meteorologists to start to really think, are we going to issue this? And then that pixel disappears, okay? The spectrum width, not as significant, it's still there. And then also the blue shows up again. We lose the green, it goes to blue. The reflectivity still does not look significant. This looks like this is bowing out. This is going to produce some gusty winds. The rotation, it's there, it's minor. But when we take a look at so many different cells as meteorologists, that does not scream out, there's a tornado on the ground. Next, this is 210. The green pops up again. And the rotation's still there. So we're getting winds of 64 miles per hour in this darker blue. The spectrum width is still the yellow area, so there's still a lot of chaotic flow there. 213, we have the blue. It's already done its damage. It's already produced a tornado. And that green never comes back. When you have not just a splotch of blue, but it's more of an arc area, this is more of a gust front. This is more of a damaging wind threat. So that storm evolved from a tornado threat when you have a clear dot of blue going into green. That is showing rotation. That's a mesocyclone that a storm could produce a tornado. But we see these a lot here in the Weather Center. And a lot of times, they don't do anything. So you weigh the odds on, okay, I'm looking at all the data as a meteorologist. Yes, there is some concern there, but it's not enough concern to go ahead and necessarily say, this is a tornado on the ground. Probably what it should have been done was a severe thunderstorm warning with a tornado possible tag with it. They issued a special weather statement with this cell. But again, you get a severe thunderstorm warning, people ignore that because it's not a tornado warning. So thank goodness it did not do more damage than what it produced. Yes, it did produce a significant damage to homes, but nobody died. And that is certainly the great news about this, with a tornado happening in the middle of the night and with no warning. That's the best case scenario that you can have, that nobody died from this tornado. Let's take a look at one other thing here, because when we take a look at the CC, so I'm going to switch over the spectrum width on the lower left-hand panel with the CC. And let's see if we can see any tornado debris signature. So there's where the tornado is. Going to put the marker here now. And what we're looking for is a clear lowering of the CC. So going from the reds into more of a green, and it's very hard to spot if there is anything there. It is blended in with what's known as non-uniform beam filling. So it's a lot of noise. There could have been a debris signature. It's hard to find. You have to have a really trained eye and you have to be sure that it is a debris signature before you go ahead and say, okay, now we have a confirmed tornado. Because if you say we have a confirmed tornado and that was noise, and you issue that tornado warning, and you wake up people in the middle of the night, that's not going to be good. So as a meteorologist, it was very difficult to identify this sneaker, is what I'm going to call it. It was a sneaky tornado. It was not on the ground that long. It popped up for one scan, and then it disappeared for the most part. So as a meteorologist, I would not feel comfortable in going ahead and saying, yes, let's go ahead and issue this tornado warning. Before we wrap up weather-wise, we are going to go ahead and take a look at the conclusion, not only with what happened with that event, but also why you did not receive a tornado warning with any of your devices. Stay tuned. All right, finally, we'll talk about the conclusion on what this event did and did not produce in terms of why there was no warning, and also looking over the actual categories, the thresholds that meteorologists for the National Weather Service have to abide by when it comes to not only issuing tornado warnings, but also what type of tornado warnings they issue. Because not all tornado warnings are created equal. You have what's known as a general tornado warning, which is rotation is seen enough that there could be a tornado. Then you have confirmed tornado warning. Then you get into a considerable tornado warning and a catastrophic or a tornado emergency. So let's take a look at Storm Track 11 right now. This is a lot of information on here. I'm going to zoom in. And first of all, this can also be found. All you have to do is just look up impact tornado warning guidance. But looking at this where my cursor is, there is the reflectivity data along with the velocity data, and they do something known as rotational velocity, or the VROT. And how they calculate that is taking the maximum pixel and then subtracting it from the minimal pixel. So basically the maximum here going towards the radar and the maximum minimal value going away from the radar, and you get a VROT of 73 knots. And that is taken into consideration on what type of tornado warning to issue. So if the VROT is 30, and then you have the STP, which is the significant tornado parameter, I'll show you that scary equation just one second, then they say, okay, a warning is needed. So if that tornado that did impact Hot Spring County, if it did not get a VROT of 30 knots, then the National Weather Service would not issue a tornado warning. And then it continues to step up as that value continues to go up. But just because you have rotation on a radar does not necessarily mean you have a tornado. So there's so much going on all at once, so much information that National Weather Service and meteorologists in general are looking at, and it's changing so fast. Those decisions have to be made quickly, but they have to be made responsibly. When we take a look at this bottom area here, this is a tornado debris signature identification rule book. So there's 4 different things they go through. They look at the velocity. Is there a rotation? Of course. And then they look at, is that rotation within the parameters of the base reflectivity showing 30 dBz. That's the value. So within a red area, or once you get into the purples and the higher the heavy rain threat or the hail threat, that's where you're going to have that co-location with the velocity couplet, or where the winds are rotating along with potentially the heavy rain. Then along with that, we look at the CC. You see the drop in CC within this example. And finally, as an extra check, you can look at what's known as the differential reflectivity, or the ZDR. And that a little more complicated, but it gives added confidence when it comes to saying, okay, this is a tornado debris signature. This is a rotation that's picking up debris and sending it aloft in the atmosphere. But look at all the different types of data that we have to go through, and all the different examples that meteorologists are keeping in mind. Does it fit this category? And of course, weather, it's not perfect. There's a gray area on what happens with a line of storms versus what happens with supercell, and if there's going to be the potential of a tornado or not. There's a significant tornado parameter. It's a nasty equation. I'm not going to go over it. You can look at that for yourself. But let's go back over to Max 1 now, because like I said, we were in constant communication with the National Weather Service as this event was unfolding. This was issued at 2:01. They highlight a cell moving into Hot Spring County north of Arkadelphia has shown signs of a mesocyclone or rotation. Rotation continues to remain broad at this time. I showed you that earlier with that rotation, looking at all the different radar products. And then before that even happened at 1:50, they did issue what's known as a special weather statement. But your NOAA radios don't get a special weather statement unless you have them programmed for that. And of course, we do not broadcast special weather statements. Otherwise, every strong storm would be broadcast, and that just gets a little excessive at times. So there was nothing screaming out to any meteorologist to say, this is producing a tornado, this is a dangerous situation. It happens, and it can happen between the scans. I've seen it before. Pine Bluff was affected by a very brief tornado back in 2019. It went through downtown Pine Bluff. It was only on the ground for a minute, but it did damage for 2 blocks, and that was an unwarranted situation. And that's because, remember, the radar beam updates every 5 minutes, and that tornado happened between the data coming in. So why did you get no warning? So here's the breakdown, here's the conclusion. First of all, Storm Prediction Center, they're the ones that issue all the outlooks days in advance. The National Weather Service works with the Storm Prediction Center to work on a watch, severe thunderstorm watch, tornado watch. And then the National Weather Service is the only entity that can issue a warning when it comes to severe weather. So every severe weather warning that you get, a severe thunderstorm warning, a tornado warning, a flash flood warning, that all comes from the local National Weather Service. And for the most part, it's here in North Little Rock, but Northwest Arkansas, it comes from Tulsa, and Shreveport takes care of Southwest Arkansas, and Memphis takes care of East Arkansas. So if there's no warning issued, the whole system collapses. There's no warning issued. The emergency manager doesn't sound a tornado siren. So you're not going to hear a tornado siren in this case when there's no warning. TV meteorologists are not going to be on air letting you know what's happening because there's no warning. They could go on air to let you know, hey, we're looking at some rotation, and we had that capability when it comes to our streaming platforms, of course, like THV 11+. You're NOAA with the radio. You're not going to get a warning because that comes directly from the National Weather Service. And any app that you have, doesn't matter what type of app you have, from whatever station you have, or even if it's not a TV station, if it's just a regular app that you got on your phone to inform you there is a tornado possibility. If that warning is not issued, nothing gets any notifications. So it's an unfortunate situation, but it's happened before, and it'll probably happen again. Hopefully, it doesn't happen in a high populated area. It makes a difference when it's over a wooded area, when there's not much population, but it makes a significant difference when it happens like over Pine Bluff, and it was only on the ground for a minute, but it did produce damage. This is a learning process. We are continuing to learn more and more and more as we get more advanced technology and more products that radar can come up with. So eventually, hopefully we don't get into this process of any more storms that are not tornado warned. But anytime you have a tornado watch, you still need to be weather aware. And that tornado watch was in effect until 2 o'clock in the morning, and then it was switched over to a severe thunderstorm watch. That's all I have here on WeatherWise. Thank you for watching. Always appreciate your comments and questions that you may have. You can send those comments and questions to my email at nscott@thv11.com. We'll have a brand new episode of WeatherWise coming up in the future. Have a great afternoon.